Now we move on to question 2. This is Mathematics Paper 1, 2023. Now we move on to sequences and series. Very interesting topic, but also very simple. The first question we have here is this a convergent geometric series? Justify your answer with the necessary calculations. So we will need a bit of help from the formula sheet for this question. So let's just quickly scroll down and copy the necessary or relevant formulae. So formulas that are relevant to the geometric series. Remember, the geometric series are series that is characterized by a common ratio. What I mean by that is that the next term is some multiple of the previous term, or some power of the previous term. There's a common ratio between the terms. So the formulas that we want to look at are these formulas right here. Let me do this in red. These formulas right here. These are the formulas that we want to be looking at. So for now, the formula that I want to copy down though is this one. Sum to infinity is equal to a first term over 1 minus the common ratio, where the common ratio, the absolute value of the common ratio is less than 1. That's what we're looking for. Let's just copy that. Now we go back to the question. Question is this a convergent geometric series? Justify your answer with the necessary calculations. And for this question, what I want you to note is that if you read 2.12, the half of the first question is already answered for you in this question. Question 2.12 is calculate the sum to infinity of this series. What does sum to infinity mean? It means that this series has to converge. Otherwise, you'll be calculating an infinite number, because if the series doesn't converge, then it means you'll be adding successively bigger and bigger numbers and subsequently getting a infinite number or a very large number. And you cannot calculate the sum to infinity of that type of series. So obviously this series has to be convergent. But then of course you have to justify your answer. And how do you justify your answer? Well, we know that for a convergent series, the common ratio, let me just paste down the formula here. Let me paste it here. This is 2.1. 2.11. We know that for a convergent series, the common ratio has to be the absolute value of the common ratio has to be less than 1, as stipulated by this condition in the formula. So we go back here and look at our series and check and look for the common ratio. From just by inspection, we can see that the common ratio here is going to be 1 over 3, because 5 times 3 is 15, 15 times 3 is 45. But then of course, doing it, we have to show that the common ratio, and how do you show that the common ratio is that? So the common ratio R is equal to U of n plus 1 over U of n, which means take the next term divided by the previous term. So we can just say 1 over 15, that's the second term, 1 over 15 divided by 1 over 5. What does that give us? 1 over 15 multiplied by 5 over 1. What is that? 1 over 3. That's the common ratio. So R is equal to 1 over 3. Now we check, is 1 over 3 greater or smaller than 1? Or minus 1. It's so 4, let me just write this down. 4 a convergent series, absolute value of r has to be less than, absolute value of r has to be less than 1. So what do we have here? R is equal to 1 over 3. Therefore, series is convergent. That's the first question. We've answered the question completely. Now, for question 2.12, as I've previously stipulated that for a convergent series, there's a sum to infinity. And the formula for sum for infinity, as I've copied it, is a over, where a is the first term, a over 1 minus the common ratio. So what is the common ratio? Common ratio is 1/3 the first term. First term is 1/5. 1/5 over 1 minus the common ratio. This will evaluate to 1 over 5 divided by 1 minus 1 over 3 is 2 over 3. This is equal to 1 over 5 times 3 over 2, which is equal to 3 over 10. That's the question 2.12 fully answered. And then the next question is next question, that's 2.2. Now at question 2.2. An arithmetic and geometric series, arithmetic and geometric sequence, are combined to form the pattern which is given by this. Write down the next two terms of the pattern. So what this question is telling you is that they had an arithmetic series x of n, which had a, b, c, d, and a geometric series z of n, which had e, f, g, h. These two were combined, and combined in such a way that there is a pattern that emerges from this combination. So, for example, they could have had A, E, B, F, C, G, and D, H. This could have been what they came up with. So now we want to see how exactly were these two sequences combined. So just by inspection, you can sort of see that the x terms appear only on the odd positions, on the odd position 1, position 3, position 5. So you could come to the conclusion that position 7 will also be an x term, and you'd be right, because that's exactly what's happening here. And the even positions, position 2, position 4, and position 6 have constants. These constants have a common ratio. Just by inspection, you can see that 3 squared is 9, 3 cubed is 27. You can sort of see this, and how you go about developing this intuition is through practice. But that's what we have there. So the two combined sequences there are x, 2x, 3x, 4x, and so on. And then for the geometric series, 1 over 3, 1 over 9, 1 over 27, 1 over 3 to the power 4, whatever that is. So the next two terms will have to come from these two places. Those are the next two terms. So here we know that, so 2.21, the answer will be 2.21 The next two terms will be you don't have to write this out, it's just for the purposes of the video. Next two terms will be 4x and 1 over 3 to the power 4. That's 27 by 3, which is 81. 81. Those are the two terms that you have there. Then move on to the next question, 2.22. 2.22. The question is, determine the general Tn, the general term Tn for the odd terms of this pattern. Write down your answer in terms of x. So what we have here, as I've previously stated, is that we have this arithmetic progression or sequence that you have there, and you can see that the general term is just in x, because in the first position, position 1, we have x, 1 times x, position 2, you have 2 times x, position 3, 3 times x, and so on. So the general term for this is just nx. That's all. That's just what you have there. And then for question 2.23, question 2.323, calculate the value of